Welcome to a lesson with Dr. Powell. Let's take a look at the derivative of sine inverse. Remember that this is the inverse function of sine of x restricted to the interval negative pi halves to pi halves. On this interval, the sine function looks something like this. Okay, and we'll also use this fact that the cosine function on this interval actually looks like this. So we'll use that in a minute. So that's cosine, and that's sine of x restricted to that interval. Okay, well, let's look at this now. Okay, let's rewrite this equation as follows. If we take the sine of both sides, then we end up getting sine of y is equal to x, since these are inverse functions of each other, especially if we use this particular sign right here. Okay, now next we take the derivative of the sine function, which we know is cosine. But we're interested in the reciprocal of this slope to get the slope of the inverse function at the corresponding swapping of x and y locations. So dy over dx will be equal to 1 over cosine y. Okay, now we have an issue. We want to rewrite cosine y in terms of x. Well, what is x? X is sine of y. So we just need to rewrite cosine in terms of sine. Do we know any identities that do that? We do. What we can do is we can say cosine squared y plus sine squared y is equal to 1. And then we can solve for cosine. We have 1 minus sine squared y, and we take a square root. Now, is it plus or minus? So this is where this comes into play. The cosine that we want will be the derivative of sine restricted. Now, sine restricted, its derivative is this cosine, and it's always positive. Hence, we want to choose the positive. So the derivative dy dx of sine inverse is equal to 1 over the positive square root of, okay, now we got to remember what sine, so we wanted to write things in terms of sine. Why? That's because sine was really x in this case. So this is really 1 minus x squared. So we get square root of 1 minus x squared. Thanks for watching.